What we're going to do now is take the material we learned in 5.2, our knowledge of factoring quadratics from the 3 days we had this week, as well as our knowledge of now zeros and roots to be able to get all the important information we need to be able to graph a quadratic function. For starters, we have our degree or polynomial name, which some of you struggled with this on the quiz even though we talked about it the day before. The degree, remember, is that it is a quadratic, and the polynomial name is going to be determined by the number of terms. And remember, polynomial name was what we had later on in the list on the quiz. We have 3 terms here, so this is a trinomial. The shape does not mean whether it opens up or opens down. This is going to be our parabola, which what made me nervous was there were a few of you on the quiz that graphed a linear function, which is interesting because we haven't graphed linear functions for 2 chapters now. The end behavior, I look at this, my a value in front of the x squared is positive. That means that it opens up. And if it opens up in that shape, it's going to have a minimum, not a maximum. A lot of you want to say max simply because it opens up and you think up maximum. Remember, our axis of symmetry is going to be found by x equals the opposite of b over 2a. And I stress the word opposite like I did in class because there were several of you that are still thinking negative b, and on the quiz b was already negative and you left it negative because you were thinking negative instead of opposite. Our axis of symmetry in this case would be x equals the opposite of b, which is 6, so negative 6, over 2 times our a value, which is 1. 2 times 1 is 2, negative 6 over 2 is negative 3. Our vertex, remember, is going to be that x, f of x, which our x is that opposite of b over 2a, and f of x is when we plug it into the equation. So that's what I'm going to do right now. And I'm going to take my negative 3, and I have negative 3 squared. Remember, if you're using a calculator, that negative 3 has to be in parentheses before the squared, so the calculator will recognize that you are squaring negative 3 and not just 3 and taking the negative. So this is plus 6 times negative 3 plus 5. Negative 3 squared is 9. 6 times negative 3 is negative 18 plus 5. 9 minus 18 is negative 9 plus 5 is negative 4. So therefore, my vertex is going to be negative 3, negative 4. Moving on to the y-intercept. Our y-intercept, remember, is our 0 c value. And if we look at our function, our c value is going to be plus 5. And so therefore, my y-intercept is 0, 5. Now moving on to the x-intercepts. Here we need to factor. And so I'm going to make a note in the margin here to factor. And so if we factor this, I see my quadratic has a value of 1, so I'm going to use a table. I need to find something that multiplies to 5 and adds to 6. Well, 5 is prime, so I know that it has to be then 5 times 1, because 5 plus 1 does equal 6, which means that I'm going to set it equal to 0 like we did in the last video, and I will have x plus 5 times x plus 1. I'm going to set those both equal to 0, so 0 equals x plus 5, and 0 equals x plus 1. Yes, you can have the 0 on the other side. Subtract 5 from both sides, x equals negative 5. And subtract 1 from each side, x equals negative 1. So my two x-intercepts that I have are going to be negative 5, 0, and negative 1, 0. Finally, go back to our good old domain and range. Our domain is going to still be all real numbers, and our range, I see here that my vertex is at as a y value of negative 4. Therefore, my range, because it opens upward, is greater than or equal to negative 4. So now I want to use all this information, and I need to mark it all to be able to get this graph going. So the first thing I'm going to do is mark my axis of symmetry, which is x is negative 3. And then my my vertex is negative 3, negative 4. And then I have x-intercepts at negative 5 and negative 1. Notice they're the same distance away from the vertex as on either side because it is an axis of symmetry. And finally we have a y-intercept at 0, 5. You need 5 points to be able to graph, and this is the only piece that's not in there. And what I'm going to do actually is in a different color. I'm going to make it symmetric. So this one is 3 units away from the axis of symmetry, so I'm going to go 3 units from the axis of symmetry on the other side. So now I have my parabola, and I just need to connect my dots. And there I have my problem. Your job now is to go ahead and try this, completing this problem with the polynomial name, shape, and behavior, marking it as a min or max, axis of symmetry, vertex, x and y intercepts, domain and range, and finally to graph it. And last but not least, please bring your questions to class tomorrow.